Third problem in kinematics. Suppose a car is traveling at 20.0 meters per second and the driver sees a traffic light turn red. After 0.530 seconds is elapsed, the driver applies the brakes and the car slows down at a rate of 7.00 meters per second squared. What is the stopping distance of the car as measured from the point where the driver first notices the red light? Alright, so we will divide the motion into two. First is before the brakes were applied, and second, during the time the brake is working. Alright? So meaning for our given, we have two parts of the motion. Okay? The first part is the car is traveling at 20 meters per second. Now, the time is equal to 0.530 seconds. Why is that? Because from 0 to 0.530 seconds, the velocity is 20 meters per second. However, after 0.530 seconds, the brakes were applied. Therefore, the acceleration is 7.0 meters per second squared. Now, this is incorrect because we are assuming that the car slows down. So therefore, if the car is slowing down, the acceleration is negative. Alright? Now, what's another given? We're looking for stopping distance. So therefore, if we are looking for stopping distance, our final velocity is 0. Because again, we are looking for stopping distance. Alright? So meaning our final velocity is 0 because the car stopped. Alright? So for our required, we need the total displacement of the car. Now, how will we get the total displacement of the car? We need to get the total displacement in part 1 of the motion and the total displacement in part 2. So meaning we can get total displacement by getting the sum of delta x1 and delta x2. Okay, let's solve for delta x1 first and delta x2. Now, we will use our working equation. So let's consider part 1 first. In part 1, what is not given and it's not required also. Yes, final velocity is not required and final velocity is not given. Okay, so we can use this equation. Delta x equals v naught t plus 1/2 at squared. Okay, so from here we can get the distance traveled in the first part of the motion. So for our solution, delta x1 equals v naught t plus 1/2 at squared. Now, 80 squared cancel. Why is that? Because we will assume that the car is moving at constant speed of 20 meters per second. Therefore, the acceleration is 0. So, delta x1 equals v naught t 20.0 meters per second times time, which is 0.530 seconds. Okay? So, 20 times 0.530 is 10.6. 10.6 meters. Alright? 10.6 meters. So, let's take note of that. That's our delta x1. So, our delta x1 is equal to 10.6 meters. Now here, since the car is traveling at 20.0 meters per second, what's the velocity here? Yes, the velocity before slowing down is 20 meters per second. So we can consider that as our initial velocity for part 2. Okay, so now you are given V final, you are given V initial, you are given the acceleration. You will look for delta x2. Okay, so what equation will we use? Now, you have to take note of the variable which is not given and it's not required. Yes, it's time. So therefore, we will use this equation. So Vf squared equals V initial squared plus 2a delta x. Do we have a final velocity? Yes, our final velocity is 0. Equals, do we have an initial velocity? Yes, 20. Do we have an acceleration? Yes, our acceleration is negative 7. Why negative? Because our object is slowing down times delta x. Okay, you already have one equation, one unknown. So we can solve for delta x. So that would be 20 squared, 20 meters per second squared. I will now transpose 2 and negative 7 to the other side. So I have positive 14 times delta x. Okay? So delta x is simply 20 squared over 14. So that would be 20 squared divided by 14. So delta x is equal to 28.57 or 28.6 meters. Alright? So now, we have the two distances or two displacements. So our delta x is 10.6 meters and our delta x2, our delta x1 is 10.6 meters and our delta x2 is 28.6 meters. So what is the total stopping distance? The total stopping distance is simply 10.6 meters plus 28.6 meters. So our delta xt is equal to 10.6 plus 28.6. So our total stopping distance is 39.2 meters. So this is our answer.